Hello, we're back with our second part of our lesson, how to make calculations with decimals. The first thing I'm going to ask you to do today as a little starter activity is to read this key point, to divide a decimal, multiply both numbers by a power of 10, 100, 1000, until you have a whole number to divide with. Then work out the division. So what I would like you to do to begin today is to do that for those divisions. You'll find that they work out quite easily when you start working on them. So don't pick up a calculator, pause the lesson, answer the questions, turn it back on when you're ready to see the answers. Okay, so here we go. So my first one, which is going to be 3.5 divided by 0.07. According to the key point, what I've now got to do is multiply both of those numbers by a power of 10 to make the divisor, the number I'm dividing by, into a whole number. So what I'm going to do is I'm going to multiply both of these numbers by 100. Times 100. If I multiply them both by 100, I get 350 divided by 7. Well, I can actually do 350 divided by 7. I'm going to use the bus stop method each time, just for consistency. So 350. How many 7s in 3? There aren't any. Carry it. How many 7s in 35? There's 5. There's no remainder. How many 7s in 0? There's none. So my answer is 50. No remainder. Okay? And that's what we do each time. So the next one, we've got 5.6 divided by 0.08. Again, in order to turn 0.08 into a whole number, I have to multiply by 100, multiply them both by 100, gives me 560 divided by 8. How many 8s in 5? None. How many 8s in 56? 7. Is there a remainder? No, because 7 8s are 56. How many 8s in 0? 0. Is there any remainder? No. So that's my answer. 70. Next one, I've got 8.4. Let's just page a little bit. 8.4 divided by 1.2. Again, no, sorry, 0.12. Let's get that right. Again, I've got to multiply that by 100 to give me 840 divided by 12. I can divide by 12 quite easily, so how many 12s in 8? There aren't any. How many 12s in 84? There are 7. Is there anything left? No. How many 12s in 0? 0. No remainder. So once again, my answer is 70. And my last one, so I've got 12.1 divided by 0.11. What am I going to multiply that by? To turn 0.11 into a whole number, I'm going to multiply it by 100. So that will give me, also I've got it here, an 11 on the outside. 121, oh sorry, 1000 210 on the inside, so I've multiplied that by 100. And how many 11s in 1? None. How many 11s in 12? 1, carry 1. How many 11s in 11? 1. How many 11s in 0? None. So my answer here is 110. So those are the answers that we should have got. Just trying to make certain you can see it all. Yes. And that's a simple skill. That multiplying out is a skill that we're going to be using a lot today. I think practically every question features that in some case. I'm probably not going to be writing down this each time from now on. I'll just be doing it and explaining it. But you must remember that this is what we're doing. We're multiplying these by a power of 10 and multiplying both the numbers by the same power of 10. Once we're underway, it's nice and simple. Okay, you might just need to, let me just see if I can get all of it on. Yeah, I can just about scratch everything onto the screen at once. If you need to copy anything down, please do so now. Then when you're ready, rejoin the lesson. So, here are some examples for you to work your way through. I mean, there's quite a few of them. So, take your time. Today could be quite a long lesson. You may find that you need to stop and come back to it at a later date, but just as long as you get it done in the time, that's fine. It doesn't always have to be done in one fell swoop. So take your time and concentrate on accuracy rather than speed. Okay, having said that, now pause the lesson and start answering the questions. Okay, now you're back to the work. Let's just start working our way through it. I've done these in advance because a lot of times there's quite a lot of work in each one of these, so it's probably better that I've got it written down. So the first one, 18.9 divided by 0.9. I multiplied both of the numbers by 10 and I got 9 and 189. How many 9s in 1? Obviously there's none. How many 9s in 18? There's 2. The remainder, how many 9s in 9? 1. So my answer there is 21. So that's my first question done. The second one, a little bit more complicated, but not a great deal. I started by multiplying both the numbers by 10 again to give me 7 and 252. How many 7s in 2? Obviously there's none. How many 7s in 25? There's 3, remainder 4. How many 7s in 42? So I've written down 7. I shouldn't have written down 7. I should have written 6. How many 7s in 42? There's 6. So my answer is 36. Oh dear. Okay, now my next question, there is quite a lot of work for. So I'm going to show you how I did it and then we can work our way through it. I started off, obviously 75. The 75 times table isn't one that I'm familiar with, but let's see how I got there to begin with. I had to multiply 0.775 by 100 to make it into a whole number, and if I multiply 39 by 100 you get 3,900. So I've got 75 there, 3,900 there. We should all have got that far. Now, working my way across. How many 7s in 3? None. Use a pencil with a finer point, that's better, isn't it? How many 7s in 39? Still none. How many 7s in 390? Right, well at this point I can say yes, there are 75s, but I don't know how many. So at this point what I started to do down here was write down my 75 times table. Well, 75 is 75, 2 75s are 150, I doubled it. 3 75s are 225, I added 75 onto this number. 4 75s are 300, I doubled 2 75s. 5 75s are 375, I got that by adding on 75 to that. And just to be on the safe side, I did the next one. 6 75s are 450. So I've got all of these 75s written down. Now I can look back at 390. Okay, how many 75s are in 390? Well, 5 75s are 375. The next one is too big, so it's 5 75s. So that's the reason why I've got the 5 there. At this point, I do a subtraction sum. 390 take away 75 is 15. I bring down my next number, which is a 0. So that gives me 150. I can look back here, look at that, 2 75s are 150. So that must be a 2. Fortunately, there is no remainder, so I don't have to do any more taking away. So my answer is 52. If you need to write the correction, I suggest you write it now, because this one is going to be there's quite a lot going on in this one. So if you need to pause the lesson at this point to write the correction and then catch up. D is a similar one. 124.6 divided by 0.35. Again, I had to multiply that by 100, which gave me 35 and 12,460. How many 35s in 1? There's none. How many 35s in 12? There's none. How many 35s in 124? There are 125s in. So there are 35s in 124. I did a little sum. I got down as far as I possibly did this one. I possibly went down to 4. 4 35s are 140. So I know I needed 3. I did a little subtraction sum. 124 take away 105 is 19. I brought down the next number, which was a 6. How many 35s in 196? Well, I'd only got as far as 145. That wasn't far enough, so I carried on. 5 35s is 175. 6 35s are 210. 196. They did 196 take away 175 because it's 5 35s, which left me 21. I brought down the last number, which is a 0. I then made certain, I can't remember whether I stopped at this one or I did this one, but I did this one at some point. 6 35s are 210. I've got 210 there. So I know that there's not going to be a remainder, so my answer is 356. E was very similar. How many 24s in 34? In 3 there aren't any. How many 24s in 34? There's 1. Brings you to 10. Bring down the 8. Gives you 108. Did a little calculation. Found out that 5 24s is 120. So I needed 4. There's the 4 there. There's the 96 there. Took them away. I got 12. Brought down the 0, turned that 12 into 120. I'd already worked out that 5 24s were 120. So I used it here and got my answer of 145. The next question was a little different. I had 43.32 divided by 0.3. I multiplied them both by 10 to give me 433.2. divided by 3. So I've still got the decimal point in this one. This is the first question where we've had a decimal point. And I'll work my way across how many 3's in 4, there's 1, remainder 1. How many 3's in 13, there's 4, remainder 1. How many 3's in 13 again, there's 4, remainder 1. I just brought the 1 across, I ignored the decimal point. It was written down, so I didn't have to worry about it. How many 3's in 12, there's 4, there's no remainder, so my answer is 144.4. And lastly, the Magnum. Now I can imagine that a few people didn't get very far with this one. But yes, the first thing that you had to do was to establish that the numbers that you needed to divide was going to be 8,230 divided by 625. This is almost exactly the same as the others. As you look here, you can see I've done all my calculations down here. I've brought the numbers down as I've worked my way across, and I've got a final answer of 13.168. If you got as far as 13.16 and gave up, that's absolutely fine. That's the process of division that we need to do. If you've needed to stop, or if you need to pause and go back through those answers, that's fine. Please make certain you've got everything written down that you need before you carry on. So I'll pause the lesson if you need to, and catch back up when you're ready. Okay, so here we go with our next questions. These are effectively the same as before. The big difference here is the question asks us to give our answers to one decimal place. So we don't need to write down more than one number after the decimal point. However, in order to round it correctly, we have to work out to 2 decimal places. That way we know whether we have to round up or round down. So as you work through these questions, you need to calculate to the second decimal point. You don't have to go any further, as I'm going to show you in a minute, and then round to 1 decimal place each time. Okay, so now have a go at these questions. And pause now and return back when you're ready. Okay, once again I've worked these out in advance purely for speed. For this one I effectively had to work out all the numbers at some point or another. Then I'll just work my way across exactly the same as we did before. Notice on this time, after I brought down this note here, I stopped. I didn't go any further because with this being a 1, no matter how I rounded it, there was no point in carrying on any further. As soon as I saw that it was 1, 24 and 40, I stopped. I wrote the 1 down and stopped. You've just stopped there. So now when I round it, I look at the 1, realise I ignore it, and I get an answer of 152.9. If you need to see that again, or you need to go through it, please pause the video and concentrate, and get your answer as you need. Otherwise, we're going to sort of get through these. The next question was what was that when I started on it. So obviously I had to multiply the numbers by 10 to give me 36. or 5.56 divided by 36, then when I started working through, obviously here's my calculations to work out the numbers that I needed. I only had to get to the end. I didn't have to go any further than this. I found 2 places of decimals. I've got a 5 there. Because it's a 5, I know I've got to round up. There's no point in going any further. So my answer is 0.2. So even though that looked like quite a complicated question, it actually worked out very, very easily. And the last one is actually a short division question, because when you multiply by 10, you end up with 7. So it's just a standard short division. I took it to the 2 places. So how many 7s in 7? 1. How many 7s in 2? None. Carry the 2. How many 7s in 25? 3. Remainder 4. Now I've gone over the decimal point. So how many 7s in 40? 5. Remainder 5. How many 7s in 50? 7. Remainder 1. I mean, it is remainder 1. I could keep going, but I don't need to, because I just need to round. I've got a 7 there, so I've got to have 1 there to get my 103.6 to 1 decimal place. So they looked a bit complicated. There's a lot of work involved, but you will get the answers. Okay, if you need any time to catch up, obviously pause the lesson. Otherwise, let's get ready for the next question. Problem solving. So we've got some words. A scientist has 27.9 grams of substance X. He needs to divide it into samples for testing. Each testing dish holds 2.4 grams. How many testing dishes does the scientist need? Okay, so here we have pretty much a standard division question. We should do this pretty quickly. So pause the tape, pause the lesson, and come back after you've answered the question. Okay, so first thing I had to do was multiply both the numbers by 10 to get the 2.4 as a whole number. So I multiplied them both by 10, which gave me 279 divided by 24. Standard division started. How many 24s in 27? 1. Remainder 3. Put down the 3. Bring down the 9. How many 27s? How many 24s in 39? 1. Remainder 15. We've reached the decimal point now. Carry on going. How many 24s in 150? Well, I remembered that I'd done 5 24s previously, so I just carried on from there. I did 6 24s, gave me 144. So I know this is a 6. That's 60. So then I've got a 6, bringing down the next 0, which is, and it becomes 60, so there's going to be 2 24s there. At this point I stopped. I know this question doesn't ask you to give to any number of decimal points, but the question says how many dishes do you need? Well, you need 11.6 dishes. Can you get such a thing as 11.6 dishes? No, you can't. You either have 11 dishes or 12 dishes. If you wrote either 11 or 12, I will accept that. Not 11.6. It must either be 12 dishes or 11 dishes. The questions like this are usually a little bit clearer as to what number that they require. Sometimes it may well be that they write each testing dish holds up to 2.4 grams. In that case, he needs 12 dishes. Or it can be that each testing dish must hold 2.4 grams, in which case he needs 11 dishes. this question, each testing dish holds 2.4 grams, isn't particularly clear. I opted in this instance for 12, but if someone decided that it wasn't 12, it was 11, I wouldn't make you lose marks because the question isn't quite clear enough. But it must be a whole number. 11.6 or any other decimal number is not acceptable because you can't have 0.6 of a dish. It's got to be a whole number. I hope that makes sense. Okay, if you need to do any corrections, pause the lesson. Otherwise, let's get ready for the next one. Okay, so we have done some division. It's now time to do a little bit of long multiplication. So do an estimate for each first, then work out your answer. Okay, this may take a little while, but that's okay. Just do the best you can. Keep going. You will get to the end. Okay, pause the lesson and get ready. When you're ready, come back and we shall look at the answers. Okay, so here are the 5 questions. 2.724 times 3.25. As an estimate, that will be 3 times 3, which will be 9. The answer will be 8.905, worked out correctly. The next one, 4.59 times 2.764, as an estimate will be 15, and the correct answer will be 12.676. 8.91 times 5.126, as an estimate will be 9 times 5, which will be 45, 45.67266. Then an estimate of 63, and the correct answer is 67.783208. And the last one, I've said an estimate of 3.5, approximately 3.5, and the correct answer 2.933775. Okay, if those aren't the answers that you got, take a while to work your way through. As I said before with these, the chances are what you've done is you've made an arithmetic error. It'll be relatively easy to spot, but make certain you find it for your own peace of mind if you need to. Okay, so obviously if you need to do that, pause the lesson. Otherwise, let's get on to the next one. Okay, so we're looking at going back to volumes of cuboids, which we haven't done for days. Well, the other side of half term. So the first thing, can you work out the volume of that cuboid? Notice that this is not the calculator question. Yes, you are going to have to do some long multiplication. And then the next one, another cuboid, has a volume of 35.52 cubic meters. It has a length of 4 meters and its width is 2.4 meters. What is its height? So we've got to sort of work a little bit backwards at this one. So, pause the lesson and make a start, please. Okay, so the first bit, we've got 3.6 times 4.2 times 9.6. 3 numbers after the question, after the decimal point in the question, so 3 numbers after the decimal point in the answer. When we work it all out, you get to 145.152. If you haven't got that, just go through your work and make certain that that's correct. Okay, now for part B, the other cuboid, it suggested that you made a sketch, so there's my sketch. I've written down what I know and what I need to know. I know that the volume is 35.52 cubic meters. I know the width is 2.4. I know the length is 4. And what I don't know is this height here. So, how did I do it? Well, I started off by writing down the formula length times width times height. Then after that I put in what I knew. I know that the volume is 35.52. I know that the length is 4. I know that the width is 2.4. So I've written those down. Then, because I can, I've multiplied those two together to give me 9.6. So I know that the height times 9.6 will be 35.52. So in order to find out what that is, I've got to effectively do an inverse operation, a reverse operation, and I have to divide 35.52 by 9.6, which will give me the height. So, writing it down and doing it, I did it long-handed again. I multiplied them both by 10 to give me 355.2 divided by 96, which gave me an answer of 3.7. So the height, so how many 96 in 35? There aren't any. How many 96s in 355? Well, 3 96s are 288. So I did that. That left me with 67. I brought down the 2 that gave me 672. I tried 7 and I got really lucky because 96 times 7 is 672, so that will be the 7 there. Nothing to remainder, so the height is 3.7 meters. So my cuboid has a width of 2.4, a length of 4, and a height of 3.7 meters. And that's the answer. Okay, if you need any corrections to be written down, there's all my workings out. Just pause and catch back up when you're ready. Okay, so now here's a calculation that we need to do that isn't actually no, that's the one. Right, Sally has £30 and 5 pence more than David. David has 2.5 times as much as Eve. Eve has £98.70. How much does Sally have? Okay, so we need to try and work out everything here. So pause the tape, pause the lesson and return back when you're ready. So I'm going to do this one right here and now. So Sally has just over £300 more than David. David has 2.5 times as much as Eve. Eve has £98.70, but we can't work out what Sally's got until we know what David's got. So the first thing I have to do is I have to find out how much David has got. So to find out what David has got, I've got to take Eve's money, her £98.70, and multiply it by 2.5. Okay, and that will tell me how much money David's got. So we're going to start with a little multiplication sum. I'm going to miss out temporarily the 0 here, just to make it a little bit easier. It doesn't matter because it will work its way back into the calculation if I need it at the end. I'm writing down the decimal points, but as you know, when we do these this type of multiplication. What I'm now going to do is ignore it. So 5 7s are 35, put down 5, carry the 3, 5 8s are 40, and 3 is 43, put down a 3, carry the 4, 5 4s are 45, and 4 is 49. Then I put down a 0 and multiply these numbers by 2. 2 7s are 14, put down a 4, carry the 1. 2 8s are 16, and 1 is 17, put down a 7, carry the 1. 2 9s are 18, and 1 is 19. So I write that down. Then I add them together. 5 and 0 is 5. 3 and 4 is 7. 9 and 7 is 16. Put down a 6, carry the 1. 4 and 9 is 13, and 1 is 14. Put down a 4, carry the 1. 1 and 1 is 2. So, those are the numbers. 2 numbers after the decimal point in the question means I need 2 numbers after the decimal point in the answer. So David has £246.75. And we know that Sally has £300.05 more. So now I've got to add £305 on. So 5 and 5 is 10, put down a 0, carry the 1. 7 and nothing and 1 is 8, put my decimal point in. 6 and nothing is 6, 4 and nothing is 4, 2 and 3 is 5. So Sally has £546.80. I hope you all got that. If you need to write down a correction, please pause the lesson and catch back up when you're ready. Okay, Susie is testing a beaker of water. She removes these samples for analysis. A, B, C and D, with different volumes in each. There's 32.4 millilitres in the beaker after samples A and B are removed. How much water was originally in the beaker? How much water is left in the beaker after all the samples have been removed? Okay, a little bit of thinking, trying to sort out exactly what's going on. Take your time, work out the answers, or pause the lesson, look at the answers, come back when you're ready. So, here's my version of the calculation. First thing that I did was I found out how much was in A and B. If you add A and B together, you get 2.135 millilitres. So, that was how much was removed, and after you removed them you had 32.4 millilitres. So before they were removed you had those two numbers added together, which is 34.535 millilitres. So that's how much water was in at the start. Now, I could have used that number to calculate by adding them all together, which is a perfectly sensible thing to do. You could have added all four together and taken it away from this total. That would have got the same answer. What I did was I just worked out C and D. I added C to D, got 3.396 millilitres, and took that away from the 3,200 that was left after A and B had been removed. I knew A and B had gone, so all I was left with was C and D. I added those two together and removed it from 32.4, which left me with 29.004 millilitres at the end. So that's how much water was left in at the end. Okay, if you need to do any corrections, please do so now. Otherwise, keep up. We keep on with the lesson. Okay, the skateboard factory. The skateboard factory makes boards from sheets of plywood. The factory checks the area of plywood wasted each week. 1 week, the total waste was 28.75 square meters over the 5 days the factory was open. Then we're given the amount of waste in 3 days. How much plywood was wasted on Tuesday and Friday? So, and also, on Friday, 2.4 meters more plywood was wasted than on Tuesday. How much was wasted on Tuesday? Okay, so, spend a little time, please. Work your way through that. So, total waste, we've said, is 28.75. The amount that was wasted on Monday, Wednesday and Thursday is these three sums added together. So I added 4.35 to 5.4 to 6.14, and I got 15.89 square meters. So in those 3 days, 15.89 square meters were wasted. To find out what was wasted on the other 2 days, I subtracted 15.89 from 28.75. Now, I realise that might be a little difficult to read there because I've put all my calculations in, but that's what I did there. When I did that, I got 12.86 square meters wasted on Tuesday and Friday. Now, it says that on Friday, 2.4 meters more plywood was wasted than on Tuesday. So how can I find out what was wasted on each day? Well, what that means is that the two numbers would have been the same apart from 2.4 meters. Yeah, because that's how much was the difference was. So if I take 2.4 square meters away, the rest of it must have been spread evenly between the 2 days. So if I do that, I got to 10.86 square meters. So if I divide that by 2, I get 5.43 meters. If I add the 2.4 on, I get 7.83. So on one day, 5.43 square meters was wasted. On another day, 7.83 square meters was wasted. So on Tuesday, 5.43 square meters was wasted. On Friday, there was an additional 2.4 square meters wasted, and 5.43 plus 2.4 gives you 7.83 square meters. That's a technique that you can use for lots and lots of questions like this, so it's really, really important that you understand this bit. This is one of those techniques that will come up time and time again when you're doing calculations, especially when they're written in context. So learn this as a technique, not just as a trick. It's not a trick, it's a technique that you can use over and over again. Okay, so please make certain you've got this one written down. This is a really, really important equation, or not equation, a technique that you can use over and over again as you go through maths. So if you need to, pause the lesson now and then catch up when you're ready. Okay, so we're now into challenges. Now we're going to do a little bit of thinking. What happens when you divide a positive number by a number between 0 and 1? What happens when you multiply a positive number by a number between 0 and 1? What happens then? So I'll leave part C to you, but have a think about A and B for a few moments and then come back to me. Okay, so what happens when you divide a positive number by a number between 0 and 1? The number actually increases. So you can't say that division always makes a number smaller. If you're dividing by a number that's less than 1, or between 0 and 1, the answer will get bigger. And similarly, if you divide by if you multiply by a number less than 1, the answer gets smaller. So there's sort of the opposite from bigger numbers. But if you think about it, if you think about what happens with numbers when you multiply them, the bigger the number you multiply them by, the bigger the increase. So there must come a point where that actually becomes a decrease, and it does, and that point is at 1. For your own what ifs, I really can't answer. I mean, one I would say is, what happens when you multiply a positive number by a number bigger than 1? It gets bigger. What happens when you divide a positive number by a number bigger than 1? It gets smaller. Those are nice and easy. If you came up with something even trickier, fantastic. Please mail it into me, please. I'd like to see. And that brings us to my reflection at the end. What's the same or what's different when dividing an integer by an integer compared with dividing a decimal by a decimal? Now this is a really so what's the same and what's different? This is a really big topic. This is something that you can really think about, because a lot of mistakes are made when people don't understand the difference between integers and decimals with multiplication and division. So this is where we're spending a few moments just thinking about, because this will affect a lot of the maths that you're doing in future. So spend some time thinking about that. If you're a bit confused by anything, drop a line to your teacher, see what they say. Well, thanks for that. I hope you've learned something. I'll see you at the next one. Bye.